I'm tackling a problem involving isotonicregression, a technique in machine learning used to model relationships between variables while ensuring the output stays consistently increasing or decreasing. It's all about finding the best fit that's monotonically increasing or decreasing. I'm answering a multiple-choice question. I need to choose the best explanations for why isotonicregression might not be producing a strictly increasing function, even when I tell it to be. I'm using a machine learning library called Sklearn's isotonic regression to build a model, but something's wrong. Even though I told the algorithm to only give me increasing results, increasing equals true, the output isn't perfectly increasing. I need to figure out why that's happening. One potential problem is noisy data. Isotonicregression assumes the underlying relationship between my variables is monotonically increasing, but noise in the data can make the output jump around and not be strictly increasing. Maybe I made a mistake and accidentally told the algorithm to produce a decreasing function, but that's unlikely, given the problem statement. If I'm using regularization, a technique to prevent overfitting, it might be set too strong, pushing the model towards a simpler, flatter solution that compromises the strictly increasing property. The model might slightly deviate from the perfect increasing line to become smoother. It's possible that there are multiple solutions that fit the data equally well, and the algorithm simply picked one that's not perfectly increasing. This would be due to the inner workings of the algorithm. I'm debugging an isotonic regression model. Isotonic regression is a method to fit a monotonically increasing or decreasing function to data. Debugging means figuring out why the model isn't working as expected. In this case, my model's output isn't strictly increasing, even though I told it to be. My isotonic regression model in Sklearn isn't producing a strictly increasing output. This is unexpected because I explicitly set the increasing parameter to true. I need to find out why. Let's dive in. I might have used too much regularization. Regularization prevents overfitting by simplifying a model, but too much can prevent it from accurately fitting the data. With strong regularization, the model prioritizes smoothness over strict monotonicity, resulting in minor deviations. It's like trying to iron out wrinkles so much that you make slight bumps instead. There could be multiple ways to perfectly fit the data while maintaining monotonicity, and the algorithm might not have picked the strictly increasing one. It's like having multiple correct answers. My algorithm has chosen one that's not perfectly monotonic. The algorithm's internal workings affect the choice. My data could have too much noise, random fluctuations. Noise violates the assumption of an underlying monotonic relationship in the data. Think of it like trying to draw a straight line through points scattered all over the place. The line might wiggle even if you intend it to be straight. This is less likely. If I incorrectly set increasing to false, I would expect a decreasing function, not a non-monotonic increasing one. It's simple, it's like asking for a dessert and getting a different dessert entirely. I'm using Sklearn's isotonic regression to model a relationship. I've noticed my model's output isn't strictly increasing, even though I set increasing equals true. Let's figure out why. If I had accidentally set increasing to false, I would expect a decreasing function, not a non-monotonic increasing one. That's not the issue here. Sometimes, multiple perfect fits exist for my data. Isotonicregression might pick one that isn't perfectly monotonic. It's not guaranteed to find a strictly increasing solution if several perfect solutions are present. If I use a regularization parameter and set it too high, the model prioritizes smoothness over closely fitting the data. This might cause tiny deviations from perfect monotonicity to achieve better overall model smoothness. Noisy data can make my fitted line jump around, breaking monotonicity. That's a common issue with isotonicregression. We need to pick every option that could create a problem even with increasing equals true. I'm tackling a problem where Sklearn's isotonic regression model, designed to find a monotonically increasing relationship, isn't producing strictly increasing results. I'm investigating why. I'm using isotonic regression in Sklearn. But even with increasing equals true, my model's output isn't strictly increasing. I need to figure out why. Noisy data can mess up the model. Isotonic regression assumes a smooth, steadily increasing, or decreasing, trend. If the data is too noisy, the model might fit the noise instead of the trend, resulting in a non-monotonic output. If I'd accidentally set increasing to false, the model would have created a decreasing function. That isn't the problem here. A high regularization parameter punishes the model for fitting the data closely. To avoid that penalty, the model might sacrifice strict monotonicity. It's possible that multiple perfect fits exist. The algorithm could pick one that doesn't strictly increase even though other options do. This is a multiple-choice question about why my isotonic regression isn't working as expected. This problem focuses on understanding why Sklearn's isotonic might produce a result that isn't strictly increasing, even when you tell it to be. We'll explore the reasons behind this unexpected behavior. You're using isotonic in Sklearn. You expect a strictly increasing output, but you're not getting one. Why? Noisy data can make it tough for the algorithm to find a truly increasing trend. Imagine trying to connect points scattered randomly. You might end up with ups and downs. Regularization helps to prevent overfitting, but too much can smooth the model too much. It might flatten parts of the output, making the result slightly non-monotonic to maintain a balance between smoothness and fit. Think of it like trying to iron a wrinkled shirt too aggressively. You might end up with some wrinkles still there. Sometimes, multiple solutions exist that perfectly explain the data. The algorithm may choose one that isn't strictly increasing, even though other solutions exist that would be. It's like choosing one path from several equally good paths, and that chosen path might have a tiny dip in it. I'm focusing on understanding why Sklearn's isotonic regression might not produce a strictly increasing output, even when I explicitly tell it to. It's all about troubleshooting a common issue in this type of regression. I'm trying to figure out why my isotonic regression model isn't always increasing, even though I've set the increasing parameter to true. Something's causing unexpected dips in the output. There could be multiple ways for the algorithm to fit the data perfectly, and it might have selected a solution that's not perfectly increasing. It's a possible explanation for what I'm seeing. Think of it like finding multiple routes that all take the same amount of time. If I've used regularization, a technique to prevent overfitting, and set the parameter too high, it might force the model to be too smooth, causing it to deviate slightly from a perfectly increasing function. The goal of preventing overfitting might lead to this non-monotonic result. Think of it as over-smoothing the model to the point it gets slightly inaccurate. My data might contain significant noise, messing with the assumption that there's an underlying monotonic relationship. Noise can cause unpredictable fluctuations, leading to deviations from a perfectly increasing model. It's like adding static to a clean signal. This title tells us we're investigating why Sklearn's isotonic regression, which should produce a steadily increasing or decreasing line, sometimes doesn't. It's a bit of a mystery. We'll explore possible reasons. I'm tackling the issue of why the isotonic regression model, even when I explicitly tell it to increase, increasing equals true, might still give a result that zigzags up and down instead of always going up. We'll look at various factors that could cause this unexpected behavior. This simply means I'm about to lay out several things that could explain why my isotonic regression is misbehaving. It's like giving various possible scenarios to the puzzle. Imagine trying to draw a smooth, steadily increasing line through a bunch of scattered points. If the data points are really noisy, scattered all over, it's going to be hard to draw that nice, smooth line without some wiggles. That's what noise can do. It breaks the rule of a monotonic relationship. This is a simple mistake. The increasing parameter controls whether the model creates an increasing or decreasing line. If I accidentally set it to false, the model will create a decreasing line which won't result in a non-monotonic increasing output. This option is incorrect. I'm looking at this possibility. Sometimes, many different lines can perfectly fit the data, but only some perfectly follow the increasing rule. The algorithm might pick one of the perfectly fitting lines that doesn't always go up. Regularization keeps the model simple and prevents it from getting too detailed. But too much regularization makes it too simple. This can force the model to create a flatter line, which may deviate a little from the data and not strictly increase everywhere. It's like smoothing out the line too much.